Rodgers, you there?
Hello, can you guys hear me now?
Yeah.
Yeah. Awesome, thank you. Yeah, so thank you everyone for joining this session. I'll go ahead and start, and I hope everyone can see my screen. Yeah, so silence means everyone can see my screen. Yeah, so
Yep.
in this session, we're going to talk about object-oriented design patterns in Angular, and specifically the gang of four design patterns. And before we start, I'm going to give a brief intro of myself. I'm Rodgers Simiyu. I'm a software developer currently working at the G2, Kenya. We are based in Nyeri. So I've been doing a full stack development, and I developed a passion in front end development and also in the backend. I've been doing serverless computing where we build and deploy software without provisioning or managing servers. Yeah. So in this discussion, I'm going to look at design principles and patterns, basically their definition and the difference between a principle and a pattern. Then we'll look at the gang of four design patterns. And finally, some of the implementations of the gang of four patterns in Angular. So we'll start off with the design principles. So design principles are guidelines that can allow us to create robust and efficient software system. We can compare the design principles to the Jenga game. I hope everyone has had a chance to play the Jenga game. So in Jenga, we have blocks that are carefully removed at a time without disturbing the tower's stability. So same case in software design principles, we are able to create software with a clear separation of concerns to ensure each component is developed and tested independently without affecting the entire system. Also, if you notice, the Jenga blocks have a uniform shape and size, making them easy to stack and remove. Similarly, in software design principles, we can achieve such a uniformity as the Jenga blocks by developing software with a modular architecture to allow the components to be easily removed and replaced without affecting the entire system. And also the Jenga game, we usually remove the blocks and place it on top of the tower and to make sure that it does not tumble even as the tower grows. Same case in software design principles, we create software with scalability in mind in order to handle the increased load and the data volumes. So next we're going to look at sample design principles. The common principles that we know are the solid design principles, which is common in object-oriented programming. We also have the do not repeat yourself principle, the keep it simple and straightforward. Some call it the keep it simple and keep it simple stupid principle, and also have you ain't gonna need it principle. But in our case, we're only going to discuss the solid principles, which is mostly used in object-oriented programming and also how it's being applied by design patterns in object-oriented. So we'll start with the single responsibility principle, which means a class should not be bloated with too many responsibilities, and instead it should only have one responsibility. And so in this case, it should only have one specific task to perform and should only have one reason to change. An example of this we can see on the left. We have a class called the customer class. It contains the information of a customer and also some ability to save that information to the database. So you can split this class and make it simple to have two classes. So on the right, you can see two classes. The first class is the customer class, which acts as a data class to hold the information of the customer. And the second class is another class to have the behavior of saving that customer information. So we're relieving the first customer class from the ability to save that customer information from the database, and we are assigning that to another class which will be responsible to save it in a database. So this could be a local database or a remote database. Yeah. So, and does anyone have any questions up until now? Okay, we can move on to the next principle. This is the open and close principle. So with the open and closed principle, um, hello guys. I hope you can still hear me. Yeah, so with the open and close principle, we have a class. We are able to create classes that can have an additional behavior without changing their source code. So in this case, you're giving the class ability to extend it without adding, to extend it without modifying the class itself. And also by doing so, we're making it flexible to modify it without breaking any of its existing functionality. So an example of this, on the left, we have a class called the payment processor. It has this specific function called the process payment function. With this function, as you can see, it handles different kinds of payment, one for the credit card and the other for PayPal. So if you wanted to add another payment process like M-Pesa, we'll have to change the source code of this particular method, process payment method. Instead, what we could do, we could have an abstract class called the payment method, and that defines the signature of that payment method. Then we'll have different payment processors extend that payment method class. So on the right, you can see that abstract class called the payment method, and we have the two different payment method processors, one for the credit card implementing that payment method, and the other for the PayPal payment method. Yeah, so this is a perfect example of the open and closed principle. So next we have the list scope substitution principle, uh, which we can use to make objects of a subclass to behave the same way as the object of the superclass. In that case, the subtypes, or in this case, the subclasses of the superclass should be substitutable by the base type. So in this case, we are able to swap objects without affecting the rest of the entire code. So an example of this, we can see on the left a class called the rectangle. It has a function called an area and the constructor that accepts two parameters, a width and a height. And the next class is a square, which extends the rectangle, but it has a different constructor, which is just which accepts only one parameter, so in this case the side length. So this violates the least scope substitution principle because a square and a rectangle cannot be of the same shape. Instead, what you can do on the right, as you can see, you can create an interface called a shape and define a method called the get area. Then you can have two different shapes, two different classes. So in this case, the rectangle and the square implementing the shape. So for the rectangle, it can have its own constructor of the two parameters for the width and the height, implementing the get area function, and also the square class implementing the shape interface with a constructor accepting a single parameter just for the size of the square, and also implementing the get area method. Yeah, so I'll move on to the interface segregation principle. So for the interface segregation principle, it requires an interface to only have methods that are of interest to it. So in this case, we should not force a class to implement a particular interface which may not use all of its methods. So in this case, we are making the interfaces to be more modular, splitting those large interfaces into small specific interfaces that can be implemented by a particular class. So for an example, we can see on the left an interface called vehicle that has three methods. So it can start and stop an engine, you can drive and also reverse. Then we have two classes implementing that interface. We have a car and a bicycle implementing the vehicle interface. For the car, it makes perfect sense to start and stop an engine, also drive and reverse. But for the bicycle, it doesn't make sense to start and stop an engine because it lacks an engine. You can only drive and reverse. So what you can do on the right, we can have two interfaces, one for the motor vehicle and the other one for non-motor vehicle. So for the motor vehicle can be implemented by the car class, which can start and stop an engine and also drive and reverse. But for the bicycle, we can only implement the non-motor vehicle interface, which can only drive and reverse only. And lastly, we look at the dependency inversion principle, where we can create a loosely coupled classes. So this can be achieved by having the high level classes that are dependent on low level classes to to rely on abstractions like interfaces or abstract classes as the dependencies instead of the concrete implementation or the concrete classes of the low-level classes. So an example of this, as you can see on the right, we have a class called an order, and on its constructor we specify two dependencies, one for the customer and the other for the product. So these are concrete classes for the customer class and for the product class. Instead, what you'll do instead, on the right, as you can see, the order class in its constructor, it relies on the customer interface and on the product interface. And with these interfaces, we can swap, we can provide a different implementation or concrete implementation of those interfaces. So in this case, we can have a customer class implementing the customer interface with its own implementation and another product class implementing its own interface for implementing the product interface. Yeah, so another advantage for this is when you're writing your unit tests, if you want to mock the dependencies of the order class, you can create like a mock implementation of the customer interface and of the product interface. But in production, we can supply the concrete implementation, the actual implementation, instead of the mock implementation of those interfaces. I'd like to ask if anyone has a question up until now. Okay, I think we're good to go. Yeah, so now we can look at the design patterns. So with design patterns, I can say these are reusable solutions to common problems that we face when we are building our software. We can also think of design patterns as the Lego game, where, for example, in the Legos, we have the Lego pieces that we can use to create different structures of the Lego game. So in relation to software design, in design patterns, we are able to add some flexibility in software design in order to build software that is more extensible and maintainable. So I'll go ahead and we'll start to look at the Gang of Four patterns. But before we do that, we need to understand the difference between design principles and the design patterns. Yeah, so we can say design patterns can be thought of the implementation of the design principles or the practical application of design principles. So for example, the Gang of Four design patterns will help us, the developers, to apply now the solid principles that we've just seen when creating our software. So that's basically the difference between design patterns and design principles. I hope everyone understood that difference. Okay, so I'll move on to this next slide. So the Gang of Four design patterns are a set of design patterns that were introduced in this particular book called the Design Patterns. The reason why it's called the Gang of Four design patterns, it's because it was they were defined by these four authors: Eric Gamma, Richard Helm, Ralph Johnson, and Johnson Slides. I hope I got the name right. Yeah, and these patterns have become a cornerstone for modern design in object-oriented programming. So we'll go ahead and take a look at some of the types of Gang of Four design patterns. We have the creational patterns, structural, and behavioral. For the creational, they focus on the mechanism of creating objects. We have the abstract factory, builder, factory methods, prototypes, and the singleton. For the structural, they're concerned with a composition of objects, so like the adapter, bridge, composite, decorator, facade, flyweight, and proxy. And for the behavioral, they're focused on the interaction and communication between the objects. So like the observers, state strategy, template method, visitor, command, interpreter, and the chain of responsibility patterns. So we're going to look at some of the patterns that are being implemented in Angular. So in this case, the patterns are the creational, structural, and the behavioral. So the advantage of using Angular in front-end development is that it comes with its own set of rules that already implement these patterns. So instead of us developers to come up not aware of these design patterns, you'll end up creating software that is complicated and hard to maintain. But with Angular, with such structured rules, it comes with this implementation of the patterns out of the box. So some of the patterns that have been implemented in Angular, for example, in creational patterns, include the singleton and the factory method. And also in the structural pattern, we have the facade and the decorator. And for the behavioral patterns, we have the observer. So I'll start off with the creational pattern. So for the creational pattern, we have a look at the singleton, which basically means we're creating a single instance of an object that can be shared across the entire application. So in Angular, we have the @injectable decorator that we can use it to mark a particular class as a singleton. So with this decorator, you can supply a property called provided in root, and in that way, that service will be available for the entire application. So as you can see in this example, we have a singleton service with that injectable decorator, and it has this property called provided in root. Therefore, this service will be available for in the entire application. So it can be used by different components and other services. And next we have the second factory method. So the factory method, you can use it to create objects that are complex to create. So in this case, you need another maybe subclass or a method to create an instance of that particular object. And maybe this method or subclass may rely on other dependencies to be available in order to create that instance of an object. So in Angular, you're able to achieve this by using the use factory method, which is available in the providers array that we can use it to create a complex objects. So just as an example, we have, let's say, this class called the my client, and in its constructor it has some dependencies. So in this case, the HTTP client. And if you want to create an instance of this particular class in Angular, we can use this providers property in the ng module. And with this providers property, we can say we need to provide an instance of this particular class. And in order to do so, we can use this factory called the HTTP client factory, which is basically a function that accepts as a parameter an instance of an HTTP client, so that with that parameter, we can provide it as a dependency to the actual HTTP client class. And also in these providers property, you can specify the dependencies that should be available for this factory to create that instance of the HTTP client. And another perfect use case for using this factory method is if you want to create different types of instances depending on some runtime conditions. So let's say on a local environment, you want to provide a different instance, maybe a one that uses maybe I'm sending a request to a local API. So you could create an instance that relies on the local API, and maybe another instance, maybe in a test environment, that's just a mock instance of the HTTP client. Then for the first aid, so this first aid pattern is a structural pattern that uses to compose different objects. So it's a simplified interface that you can use to encapsulate a complex system. So in Angular, we have seen this in services and components, whereby we have a service that can communicate with a remote repository or a local repository. Then we have a component that relies on that particular service to consume the data from that service, instead of having that logic of communicating to that local or remote repository inside the components. So we can see this in these examples. We have a service called the API service that relies on the HTTP client to send requests to a remote API. Then we have the component that only accepts an instance of the API service to fetch data, let's say a user's data. So the logic of fetching this data is encapsulated within the API service. So the component is not concerned with how the data is being fetched, but all that task has been assigned to the API service. So the API service encapsulates all that complexity of fetching that data. So this is a perfect example of this first aid pattern. Another example of the structural pattern is the decorator, whereby you're able to add some functionality to an object without modifying its initial behavior. An example in Angular is interceptors. So I can just show you an example of an interceptor. So on the left, we have an auth interceptor that implements an HTTP interceptor. What it basically does is to check if there's a user session already existing in the application. And in that case, if there's a token that indicates that there's a user session, it will add that token to the authorization header for every request that requires authorization. So instead of writing this logic repeatedly in your services that have an HTTP client that sends a request to to some URL that requires authorization, you can just encapsulate it in an interceptor, and this interceptor will dynamically add, this behavior for checking the user session and adding the token to the request in one place instead of repeating that logic on every HTTP service. Then we could, I think I added the wrong slide. Yeah, sorry for that. Yeah, then we could register this HTTP interceptor in the ng modules as an interceptor for the HTTP interceptor. And next we have the observer pattern. So this observer pattern is part of the structural creation. Yeah, so maybe one of you guys can remind me the example of the patterns that we had in the Gang of 4 patterns. We had the creational, structural, and the behavioral. So the observer pattern is a behavioral pattern that you can use to add communication between objects. So in this case, in Angular, we've been using RxJS to add communication between objects. So for example, for when you have two components, so let's say sibling components that want to communicate with one another, you could create a service, and with this service, you could use a behavior subject or a subject, so that with that subject, you're able to send notifications between these two sibling components. Because if it were only communication between a parent and a child component, you could use the input and the outputs to communicate. But for sibling components, you could use a service that encapsulates a behavior subject to send notification between these sibling components or any components that are not related to each other. So with the service, you can mark it as a singleton, again using the provided in root property. Then it will have that subject that you expose it as an observable, and making that and with that observable, we're able to send notifications between two components. So in this example, we have the sender component and the receiver component. So for the sender component, we're able to send messages by calling this a change message that's being exposed from the data service. And basically what it does is to call next on the observable, on the messages subject, which now provide the new message that will be available to this receiver component. And this receiver component, what it will basically do is to access the current message that exposes the subject as an observable and subscribe to any messages that are being sent through the change message method. So that's basically the observer pattern, which is just a behavioral pattern in the Gamma 4 design patterns. I think I've exhausted all of some, not all, but some of the patterns that have been implemented in a Gamma 4 patterns by Angular. If you guys encounter some of the patterns, I'd like to hear from you. But these are some of the common patterns that have been implemented in Angular. So I think, yeah, so that's all from me. That's all from this session. So right now it's perfect time for you guys to ask any questions.
If anyone has a question, please feel free to unmute yourself and ask. Okay, probably for me, it's just to look at on what you just presented on in terms of design patterns.
Yeah.
What's your take on writing clean and reusable code, but also making sure you don't lose sense of what your app is all about? So for example, a beginner, like does a beginner just go ahead and do things like creating your HTTP client, like tapping into HTTP requests in the same area where you have your component and all that? Or should also beginners start looking at how can I modularize my application?
Yeah, sure. They should start looking at how to modularize modularize the application. So in terms of separation of concern. So in my case, when I had started working on Angular applications, I always had this question on why should I use a HTTP client inside a service when I could just inject it directly inside a component. And then I had encountered this pattern, the facade pattern, whereby instead of using the HTTP client directly inside the component, I can encapsulate it inside a service. And in that way, whenever I'm writing my unit test for the component, I can mock an instance of that service, so that if I'm just unit testing the component, I do not have to make an API call using the HTTP client. I can provide a mock instance of that service that, let's say it has some dummy implementation of the HTTP client, does not send an actual request to the API, so that I have clear separation of concern between the functionality of the component from that of the HTTP client using a service. Then if you want to do some integration tests, I can now provide an actual implementation of that service, so that I can make sure the component can actually communicate with the service, which can actually send the actual request to the backend, just to make sure that everything is working fine. And also it is easier to maintain code that has some modularization. So I'll know that with the component, it has a clear concern of dealing with the views side of things. And then for the service, has a clear concern on dealing on the business logic side of things, or the repository side of things. Yeah.
Okay, thank you for that. Yeah. And I think I don't know if you've probably had a try at things like standalone components right now in Angular. Have you given a try at it?
Yeah. So at first, when
Do you have? Yeah.
Yeah, so when I my first interaction with Angular was working with modules. I was thinking of working on small applications. So it didn't make sense at that time using Angular to create a small application, because I'll need to have to maintain that applications in terms of modules. So Angular was best meant for enterprise applications. So when standalone components were introduced, that's when I was thinking of using Angular to create small applications, unlike using a framework or library like React. Yeah.
Thank you. Anyone else who has a question?
Yeah, I have one.
Sure.
Yeah, Rogers. I think my question is, are there any drawbacks to using such design patterns? Because in my mind, I'm thinking the learning curve, it's like, what are the advantages to using the design patterns compared to someone who is not using the design patterns?
I could say it has more advantages in terms of the learning curve, because let's say you're a new developer on on an application that's an application. So this is an application that has existed for some time. If that application had no implementation of these design patterns, it will be easier to understand how that application was being built, and also to maintain it. It will be hectic compared to an application that has all these design patterns implemented, because these are like standard rules on how to create a maintainable software. So if you understood these design patterns, it will be easier enough for you to understand how that application was maintained, created. And also, if you want to add new functionality, it will be easier to extend it. And creating applications using Angular is much easier, because already Angular has some of these patterns implemented. So it won't be it won't be that hard to understand such an application and to maintain it.
Oh, all right. Yeah. So, what if you are working on a existing code base that does not have any design pattern? So, how would you go about
So the
adding
code
that?
that does not have design patterns, it is very difficult to understand it, because the person who had created that code base used their own ways of creating such software. And maybe if they were not aware of these design patterns, they'll have to come up with better design decisions on how they could create their software. And such approach is hard to create a perfect design that makes your software to be flexible and easy to maintain.
Yeah. Thanks.
Okay, hi, Rodgers. I have a question. So,
Yeah.
how do you know which design person should you use in your Angular project?
It depends on the use case. So, for example, let's say for communication between a parent and a child component, for that case, you want to use an observer to establish such a communication, because you could use whatever Angular already implements. So let's say using inputs for the child to receive data from the parent, and maybe output to send events from the child to the parent. But if you have two different components that need to communicate, then you'll say, okay, I think I need an observer pattern to establish communication between these different components. So in that case, I can use RxJS with behavior subjects and subjects to send notifications between these two components. So it basically depends on the use case.
Yeye afikirie mkono ni madunya.
Winnie, I hope I got your question.
All right. Okay. Thank you. Yeah.